All right, let's talk about more properties of exponents. In this video, I'm going to show a little bit more complex problems using properties of exponents. If you haven't seen or understand the very basic properties of exponents, I suggest you watch my first video on properties of exponents before you watch this one. So this one, I'm not going to spend as much time explaining the properties. I'm just going to start applying them all in more complex problems. So this first one, I have 3x squared y to the negative 3 divided by x to the negative 3. So there's a few things I see here immediately. I immediately see negative exponents, and I see a division sign there. So what I like to do is really tackle those negative exponents first. So I need to look at what's moving. So remember, only bases that have a negative exponent attached to it are going to move. So this 3 out front, this is really like 3 to the first power. So that doesn't have a negative exponent. So the 3 was in the numerator at the top, so it's going to stay up top. So I have a 3 up there. Moving along the top, I have an x squared. Well, that's a positive 2, x squared. So that x squared is going to stay in the numerator as well. Next, I see a y to the negative 3 power. Again, when you have negative exponents, if it's on top in the numerator, it's going to go to the bottom. It's reciprocal. So that y to the negative 3, that needs to come to the bottom as a y, but instead of negative 3, it's going to be a positive 3 now. And in the denominator, I have x to the negative 3. That is also a negative exponent. It was on bottom. That needs to move to the top. So a reciprocal there again. So that x to the negative 3, that's going to move to the top, and it's also become positive. So I took care of the negatives there, which is a great start. The other thing I'm noticing here is, notice I have multiple x's here. I only have this y. It's already condensed down to 3. But I need to do something about these x's. So I'm not quite sure exactly what's going to happen. So using the rule of thumb, when in doubt, write it out. So this 3 only have one of them. So I'm going to write a single 3 there. If you have x squared, that's the same as x times x. And then I have an x cubed, which is x times x times x. And then denominator, I have y times y times y. So I kind of expand everything out just to make sure everything is going where it needs to be. Now, a lot of students try and skip steps here and there. I don't suggest that. That's where a lot of mistakes are typically made. So I'm ready to condense this down. In the numerator, I just have this single 3, so I'm going to still have my 3. Next, I have a whole bunch of x's here, and they don't cancel out with any x on the bottom. So I have 1, 2, 3, 4, 5 x's. So that's going to be an x to the 5th. In the denominator, I have 1, 2, 3 y's. That's going to be my y to the 3rd. So my answer there is 3x to the 5th, y divided by y to the 3rd. So moving on to a little bit more complex problem. Again, I see negative exponents. I see parentheses here too. So with 3x squared y and a negative 2 on the outside. I don't like having parentheses there. Just like in typical problems, we like to distribute whenever there's parentheses. That's going to be the same here. But again, we're dealing with exponents. So I'm going to distribute with the exponents. So I kind of need to know, well, what is even in my exponents in the first place? So this 3 has an exponent of 1. That x has an exponent of 2. This y has an exponent of 1. So whenever it doesn't look like it doesn't have an exponent, don't just assume this 3 has an exponent of 2 as well. That's not the case. And then on the outside, I have this negative 2 still. So the property here is whenever you have an exponent on the outside of the parentheses on the inside, what we're going to do is we're going to distribute or multiply. So I'm going to take this negative 2 times the exponent of 1. So I have 3 to the negative 2. This negative 2 to the other 2. Negative 2 times 2 is negative 4. And then negative 2 to 1, which is negative 2. So I get 3 to the negative 2nd, x to the negative 4th, y to the negative 2. So I got rid of my parentheses. Now I have to really worry about those negative exponents. Now just like this problem here, whenever you have negative exponents, you know, if you're in the numerator or the top, you're going to move to the bottom. If you're in the denominator or the bottom, you're going to move to the top. So we're doing reciprocals here. Looking at this problem, I don't see a top and bottom. So I kind of like to make that a little bit more obvious so it's easier to see on a visual point. So all of that is still there, except the only issue is the denominator is really just dividing by 1. Because if you divide anything by 1, that doesn't change it. It's the exact same thing. So I like to do that just to show, where's my top and where's my bottom. So I need to go through and simplify this and try and figure out what's going to end up on top and what's going to end up on bottom. So I start off with a 3 to the negative 2. Since that has a negative exponent, that 3 to negative 2, it's going to come to the bottom, and it's going to change to a positive 2. So we have 3 squared on the bottom. You could also write 9. I like the square being there just to kind of show how the property works. Moving on to the top, I have x to the negative 4, another negative exponent. So that was on top, it's now going to be on bottom, and it's now going to be positive. And then finally on the top, I have a y to the negative 2, was on top, but does have a negative exponent. So that's going to come to the bottom as well as a reciprocal. Then you have y to the positive 2. That 1 is technically still down there because it does have a negative exponent, so multiplying this by 1 doesn't change anything. The question becomes well, what's on top? Well, everything on the top went to the bottom, but you don't just say, well, there's nothing there. What happens when everything's gone like that is we really have just the number 1 left. So we're going to have 1 divided by 3 squared times x to the 4th times y squared. So let's go to our last one here. And there's a whole lot going on here, but you're going to see it cleans up nice. So we have 3x squared y to the 4th times 4x to the negative 3rd y to the negative 2 z to the 0. So a lot going on here. Again, I see the negative exponents, and immediately I want to figure out what's on top and what's on bottom. Again, there is no bottom here, so what I'm going to do is I'm going to write in divided by 1. And then let's go ahead and start moving things around and see what happens. So I got this 3. That does not have a negative exponent attached to it, so I'm going to leave my 3 there. Remember, that's like almost 3 to the 1st power. I got this x squared. Well, that doesn't have a negative exponent, so that's going to stay up top as well, x squared. I have this y to the 4th. Still no negative exponent, so leave it there. Next, I have this 4. Don't get confused and think this negative 3 is with the 4. The negative 3 is with the x. This is like 4 to the 1st power, so that 4 is going to stay on top as well. This x to the negative 3, that base of x does have a negative exponent attached to it, so it was on top. That's going to come to the bottom. So now we have x to the 3rd. Next, you have y to the negative 2. That is another negative exponent. Was in the numerator. Now going to be in the denominator. Now going to be positive, so y squared. And last, we have this z to the 0 power. Now, it might be hard to remember, but remember, anytime you have anything to the 0 power, that is always 1. So my z is actually gone, and I just have a multiple of 1 there. So I got rid of all the negative exponents and an exponent of 0. Only thing left to do is kind of simplify and compact this down. Again, I'm not exactly sure how the rules apply, so when in doubt, write it out. So I have a 3. I'm going to start with the top, and then I'll work my way to the bottom. So I have this plain old 3 up there, so I'm going to write my 3. I got an x squared, which is just x times x. I got a y to the 4th, which is, there's going to be 4 of them there. 1, 2, 3, 4. And then I need to multiply by 4 and multiply by 1. In the bottom, or the denominator, I have x cubed, so 3 x's. 1, 2, 3. And a y squared, which is y times y. Only thing left to do is look and see what things kind of divide or cancel out. So I can take an x from the numerator, x from the denominator, x from the numerator, x from the denominator. No more x's up top, so this x is going to stay there. I can do the same with y's. So I got a y on top and bottom, another y that I can take away from the top and bottom, and nothing else. So now I just need to condense this all down. So I like to look at the numbers first, and then I'll move to the variables. So I have 3 times 4 times 1. So 3 times 4 is 12. 12 times 1 is 12. So I took care of the 3, 4, and the 1. I have a y times a y, which is y squared. In the denominator, I just have this plain old x, so I'm going to put x. And those were a few examples using properties of exponents.